So today we will understand what is this transport layer security, that is TLS, and how to implement TLS for web servers, how TLS is used to authenticate the users in Kubernetes, or how TLS certificates are used for authentication in various components in Kubernetes. Okay, so we'll understand a lot of topics in this particular video. Okay, so we'll see why TLS or SSL is needed, difference between cryptography and encryption, what is hashing in cryptography and how it is different from encryption. Okay, so we'll see what is symmetric and asymmetric encryption, what is HTTPS protocol, what is SSL or TLS handshake, and why this is required, client versus server certificates, certificate authority, PKI or public key infrastructure, SSL certificate types, what are self-signed certificates, what are the advantages and disadvantages of SSL certificates, self-signed certificates. We'll also understand OpenSSL utility for creation of all the private keys and certificates using this utility. We'll understand the importance of CSR, okay, which is certificate signing request, why this is important. Okay, and another important topic, that is subject name alternative or subject alternative name, also known as SAN, why this is required. So what happens if you don't provide SAN? Okay, we will also see how to create our own certificate authority. Okay, at the end we will understand the X.509 certificate format and how to decode certificates and certificate signing requests. Clear? So there are a lot of things that we will understand. Okay, so these are all required for understanding how users authenticate themselves with the API server of Kubernetes, how to enable HTTPS protocol on the web servers. We'll see a lot of hands-on demos as well. Okay, clear, guys.
Yeah, Vikram.
Okay, so whenever you send try to send information on the internet, usually it has to go through a lot of hops, which means it has to go through a lot of networking devices to reach your destination. Okay, and here if I try to show you, so if I assume that this is your web browser and you're trying to basically access an application on the internet. Okay, so directly there won't be any connection, which we already know. Okay, so it has to go through a lot of networking devices in order to reach your, this is your, let's say, your web server, which is actually hosting your web application. Let's say for simplicity, let's say kubernetes.io. Okay, so this is the website you're trying to access. Now when you're trying to access the application, okay, in case if the other application is not related to any banking application or any application that is storing some information about the users, that is completely okay. But what if instead of this kubernetes.io, so you are visiting your banking application or anything like that? Okay, so what will happen in this case? Let's say you're trying to log in into your bank to fetch your balance or do some transaction. Okay, so if the data is sent across the internet, so anyone in the internet can see that information, right? Correct? They can see the traffic that is going through the network, and then they can sniff and then they can extract your data. Correct? Correct, guys?
Yes.
So this is, let's say, unauthorized user. Okay, someone who is trying to sniff on your traffic and trying to gain access to your data so that he can use that data to log in into your banking application. Let's assume the data is not encrypted or anything like that. So the data is being sent in a plain traffic. That is, your user ID and password are being sent in the plain traffic. So anyone who can read the data, they can easily understand that data. Okay. Now let's understand. Okay, so what will happen? So let's assume, so the data is not encrypted, so anyone can read your data, and sometimes your data can be very sensitive and valuable. So the hacker can gain access to the data, and then he can log in into the application, and this will lead to financial loss for you. Okay, and the applications can be your web applications or banking applications, or it can be web applications that require login credentials. Okay, so anyone gets those access credentials, they can easily log in. Okay, so these are some of the security challenges that you encounter while you send information online. Okay, the first thing is, so here let's assume I need to contact the bank. Okay, so how do I know that I am exactly talking to the banking application, which is the genuine banking application? Okay, so what if there is one more bank application which is hosted by some hacker? Okay, so with the DNS name, let's say instead of 1K, so there is this double K bank.com. Okay, so instead of me accessing bank.com, let's say, I'm not sure about the bank DNS, so I trying to access this bank with the double K.com. Okay, right? Now how do I protect myself? So how do I identify whether this is the genuine banking application or not, right? And the thing is, let's say if bank sends any information to me, so how do I know that the data which is coming to me is not changed in the transit? Okay, let's say bank sends some x equal to 1. So what if someone tries to modify it x equal to 2 and I receive x equal to 2? So how do I make sure that the data is not corrupted or not changed in the transit? Okay, so these are the various security challenges, right? Correct. And also, how do bank itself authenticate the users, that is the genuine users? Okay, so how do bank knows that the user who is trying to log in is the actual user, but he is not unauthorized user or some hacker trying to access the website? So these are the various challenges that we will encounter. So usually this will occur when you're trying to access HTTP sites. Okay, so HTTP, we already know that using HTTP the data is sent in the plain format. Correct?
Yes,
Right,
Vikram.
guys? Okay. So now in order to protect your data, you know, so a new standard has been developed, which we call it as transport layer security. Earlier, we used to call it as SSL or secure sockets layer. So now it is transport layer security, the next version of SSL. So both are same. Some use SSL certificate, some use TLS certificates, some say TLS protocol, some say SSL protocol. Both are same, but the correct name is TLS. Okay, so we'll understand TLS certificates, everything in detail. Okay, so right now we are trying to understand the concepts behind the encryption, cryptography, and the rest of this stuff. Okay, so before implementing those TLS certificates or HTTPS protocol, let's understand what is cryptography. Okay, so cryptography is an art of encrypting information so that the unintended recipients cannot actually understand or decode that data. Okay, so it is not any algorithm. Okay, or it is not a process. So it is just a area. Okay, it is a study area in which we understand how to encrypt the information, in how many ways you can encrypt and decrypt the data, so the unintended recipients or some hackers cannot actually read the data. Okay, so in cryptography, so we convert a plain text. Okay, if I say hello world, that is a plain text. We'll convert them into something random which cannot be understood that easily. So that unreadable text is called ciphertext. Okay, and ciphertext is very hard to decode. Okay, I'll tell you why it is very hard to decode. Okay, so here cryptography means it is something like writing something which is not decodable. Like it can be decoded, but it is not easy to decode, so that's why it is called hidden writing. Okay, see, encryption is also the same thing, right? Encrypting means you're encrypting the data so that the others won't understand it. But there is a difference between encryption and cryptography. So cryptography, it is an area of, uh, you know, it is a study of methods like encryption. So encryption is a process inside cryptography. So you can say cryptography is just an area where encryption implements cryptography, where cryptography says how to encrypt the data and decrypt it, but encryption actually implements that process. Okay, understood, guys? So your cryptography might have a lot of encryption algorithms. Okay, but actual encryption is the process. How do you encrypt and decrypt the data? Clear? Now there are two types of encryption, or you can say cryptographic techniques. Okay, so one is the symmetric key cryptography. So what is symmetric key cryptography? Okay, it is an encryption where we encrypt the data with a key and also decrypt it with the same key. Okay, so it is the common key that both sender and receiver should have. So sender will encrypt the data with that key, and the receiver will also decrypt the data with that key. Okay, so here the problem is you need to have this key with both sender and receiver. Correct? Correct, guys?
Yes.
Okay, so here you have the sender, here you have the receiver Rx, let's say. Okay, so you have the data hello world, and then you encrypt with a specific key, let's say. Okay, so in order to decrypt it, you should also have the same key with the receiver. But the question here is, how do you send this key from sender to the receiver, because both of them should have the same key. Okay, so what if you're sending through the network and the attacker or the hacker also gets access to that key? Okay, so he'll also have that key. So whatever you're sending, like the hello world, if you encrypt it, let's say it has this as encrypted data. Okay, so here I will receive it on the receiver end, and then using the key, shared key which you have shared, he can decrypt it like this. But the problem here is that encrypted data also will be seen by the hacker, and since when you're trying to send the shared key to the receiver, he also got it, and similarly he can also decrypt it. Correct? Correct, guys? So here this particular symmetric key encryption is faster because there is only one key involved, but the problem is you need to find a way to share the key with the intended receiver. Otherwise anyone can receive that key, and they can themselves decode it. Okay, now what is asymmetric key cryptography? So in this key, so you'll have two keys. In this approach you'll have two keys. One is the public key and the other one is the private key. Okay, so here you have to encrypt the data with one key, and you can only decode it the other key. Okay, clear? Using public key, usually we encrypt the data. Using private key, you can decrypt the data, but it is not like that. Since these two keys are cryptographically related to each other, you can actually use private key to encrypt and public key to decrypt. So there is there is no mandatory requirement that you should only encrypt with public key. It's not like that. But if you are encrypting with one key, you cannot decrypt it with the same key. You should use the other key. Okay, understood, guys? Got it? So this method is also known as public key encryption, okay, which I'll tell you in some time. Okay, so using this asymmetric key, you will have two different keys, public and private key. So a user will, basically generate two keys, the public and private. Okay, so what will happen in this case is the private key should not be sent to anyone. Okay, so it can only be stored with you, but public key you can share it with anyone because it is public. Got it? Now there is a third method in cryptography, that is hash functions. Okay, so these hash functions we have used many times, but we will not we never realize that it is a hash function. So hash is, here you will not have any keys kind of method here. Okay, so here hash is nothing but a fixed value. It's a random number. So you take any data and then you convert into a hash value. Okay, let's say you have a plain text. Okay, then using some functions you will actually convert into hash. Once it is converted into hash, there is no way you can get the plain text back, which means hashing is not encoding and decoding or encryption or decryption. It is a way of converting your data into some other format which cannot be recovered. Okay, so it is a one way function. It is not like encryption and decryption, which is a two-way function. It is just one way function. You can only change your data into something known as hashed text. Okay, clear, guys? So both hashing and
What is
encryption comes
hash
under the
test?
crypt. I'll tell you. Okay, so both hashing and encryption comes under cryptography, but here hashing is it's not method of encrypting and decrypting the data, but it is a method of storing the data. Okay, so what happens in case of hashing is you send your plain text into a hash function. Okay, and then it will convert into something which is very secure, and it is not easy to decode it. The main function of hashing is not to send the data so that the others can decode it. The main function of hashing is to store the data securely. Okay, I'll tell you the use cases in some time. Okay, so here, yeah, so one thing is storing the passwords. Okay, so in case if you see in your Linux machine, your passwords will not be visible. Okay, all your passwords are stored in the form of hashes. Correct, right? So how do you log in then? So let's say my login ID is let's say dev, and the password is admin123. Okay, so this is the password admin123. So how this admin123 is stored is it is sent to a hash function, and then it will generate a hash value. Okay, which is very hard to uh, you know decode. Then it is stored in your system. Okay, right? Now next time if I log in, I'll enter admin123. Okay, so now what system will do, system will try to calculate the hash value of this. Now it will calculate this newly created hash value, newly calculated, and the one which is originally stored. If both these values are equal, then only it will authenticate you. Okay, understood? So here if you see, it is not actually trying to compare your actual data. Okay, so your data is compared with their hash values. Since hash values are available in the system, and even if I log into the system and try to decode or decrypt this hash value, I will not be able to see the password. Okay, clear guys? Understood guys?
Yeah, got it.
The third one is integrity of data. So integrity of data also we have seen in multiple scenarios, but we did not realize that it belongs to hashing. Okay, so let's say I have a file in the server. Okay, this server is hosting a file known as Helm binary. Let's assume Helm binary. So now I need to download it. Okay, I downloaded it. Now in my client, which is my local system, I downloaded the Helm binary. But how do I know that I downloaded the entire binary, or some binary which is corrupted? Maybe due to some network issue, some packets are lost, but Helm binary is downloaded. But this binary is not equal to this binary. So how do I confirm that the actual binary is downloaded? Okay, so that I can be rest assured that no one modified this while I downloaded it. Okay, or let's assume you have a PDF file that you're trying to download it from the server. You download it, but how do I know that this PDF file is downloaded without any modification? So what if some hacker just modified it when I'm downloading, and then he gave his own PDF file which is full of some malware or something like that? Okay, so here what we can do is, what server does is, when it actually hosts that file, let's say a PDF file, some PDF file. Okay, so here it also maintains the hash value. Okay, so this hash value is calculated according to the content in this PDF file. So this hash value 123. Okay, now what I can do is, once I download this PDF file, I can calculate the hash value of that file. Okay, so if I calculate the hash value of the file, I'll get some number, a value. So if this value and this value matches, which means no one modified my file, or the file is not corrupted while downloading. Okay, clear? Now if you go to this Helm binary download, that is the GitHub release pages, you will find this checksum or the hash value. Okay, So your checksum is the result of the hash function. You can say that hash value. Okay, so here hash value is created according to the data. And once you download the file, what you can do is you can calculate the hash value of that file. Now that hash value which you are calculating should match the hash value of this. Okay, in fact I can quickly show you that as well. Okay, so let's go to Helm download, installing Helm, releases. Okay, so here if you see, this is the hash value. Okay, so let's see how to calculate the hash value. Okay, so for this I'll launch an EC2 instance. So I'll call it as some demo machine, or let's say a web server, because I will be installing something in this. I'll take Linux AMI only. Okay, and keyware I'll choose the one which I have, otherwise you can create one. And I don't require anything for now. I'll just launch the instance. Okay, now let's see how to calculate hash of a file. Okay, so there is this function called SHA-5112. Okay, so we can use that, but let me see the proper command. This one. Okay, SHA-1 sum, or I think SHA-5112 should also be there. So by the way, SHA is, I'll tell you again what is SHA. Here, so it is SHA-5112. Okay, SHA-5112, and then I can use the file which I downloaded. Okay, getting guys what I'm trying to do, guys?
Yes, yeah, Vikram, got it.
Yes, any questions? So here I'm trying to modify some session which I already have. I changed the IP address. Okay, so I'm just switching to root user. What I'll do is I'll try to download this particular file. Okay, so Linux AMD 64. Just copy the link address and then just use curl hyphen capital O and that file. Okay, so if you see, the tar file is downloaded. Okay, now how to calculate the SHA value of that? It is SHA-5112 sum followed by the name of the file which we downloaded. If you see, it is CC75AE, something like this. Okay, so then this is different, which means this is uh, a different SHA calculation. SHA-256 sum. Okay, so let's try to calculate the SHA-256 value. If you see 78D82, you can see here, right? Correct. So both are same. It means whatever file I downloaded, it got downloaded exactly without any modifications. Correct? Understood, guys? So
If you
this is
change
how
any
you,
file in the download file, it will change outcome. That SHA value.
yeah. So if you try to download, after downloading, if you modify that file and try to check, it will be different because you modified the file contents. Okay. So this is usually used when you try to send some data and you want the recipient to exactly receive the data without any modifications. Then you, after you receive the data, you can calculate the SHA value, and then you have to compare the one with the original file. Okay, so if both match, which means same data is received. Okay, so data is not corrupted. Okay, So here there are many hashing algorithms like MD4, MD5, SHA-512, okay, SHA-256. Okay, so here this 512 and 256 is the fixed length of string that you will get once that particular file or the data is sent to the hash function. Okay, so you will get that particular length of the data. If it is SHA-256, it is 256 bits, like that. Okay, and this algorithm is used mainly when you're sending some files, or downloading some files, or storing the passwords. Okay, so where exactly we'll store all the passwords in Linux system?
etc path stability.
No, etc shadow.
Shadow.
Okay, if you see inside shadow, you'll not find any passwords, they're all hashed values. Okay, encryption and decryption. So encryption, again, it is a process of turning in plain text into a ciphertext, right? So here we'll use keys to encrypt and decrypt the data. So your original text will be converted into ciphertext using those keys. And we have symmetric key and asymmetric key encryption, like symmetric and asymmetric cryptography. And in symmetric encryption, you'll use the same key for encoding, I mean, for encrypting and decrypting the data. Okay. In asymmetric encryption, you use public and private keys. So public key you'll use for encrypt, and private key can be used to decrypt the data. Okay. In fact, we already use this method of encryption in passwordless authentication, if you remember, right? So what we do generally, we create two keys, right? So one is the public key and the other one is the private key, that we usually do with SSH keys in, correct? Understood? So what we'll do,
Yes.
we will use SSH keys in, and then if you see here, under this there are two files that are downloaded, created. One is id underscore rsa, which is private key, and this is the public key. So usually we put our private key with us, and public key we will put on the remote servers, correct? So being a user, I'll have both public and private keys. And then if you have the remote machine, okay, so you will put your public here. So this public here means it is kind of a lock. Okay, and then you can use your public key to lock multiple machines, and you can only unlock it with the private key. So usually private, this is the key, you can say public, it is also key, but you can consider it as a lock in case if you want to understand. Similarly, multiple people will put their own locks, that is, they'll put their own public keys on the remote server. So where exactly all those public keys will be available? Okay, it is under .ssh authorized keys. So if you open this file, you'll find the public keys of all the users who logged this machine. Got it? Clear? Any questions, guys? Okay, so usually the question comes is what are the formats or file extensions of these files? Okay, and don't get confused about these certificates yet. Okay, so for now, just remember that a certificate will have your public key. Okay, you have to blindly remember this. A certificate will have your public key. Okay, whenever I say certificate, it is a public key. Got it? Okay, so certificates and public keys usually have .crt. Private keys will have .key, but many times you will see in the .pem. So basically pem is the format that can contain anything. Okay, as we already know that inside Linux, okay, so there is no importance to the extension, it is importance to the data inside it. Okay, so pem is the format that can store your public keys, private keys, certificates, everything. Okay, But how do I identify whether this is a key and a certificates? How do I differentiate? Usually all certificates will have .crt, all keys will have .key. Otherwise, let's say I have generated two keys, one is the certificate, the other is key. Okay, if server .key, if if .key is the extension for this server, then this is the private key. Otherwise, sometimes you'll also have this kind of key name followed by the pem. Okay, so if you have server.pem, remember that this is the certificate, but if you have a key, then that is the key. Okay, clear? So usually it is CRT and key. It's a standard naming convention. Then which is better? So we are talking about symmetric and asymmetric encryption. So which is better? So usually, symmetric key is much faster because it has only one key for encryption and decryption. Okay, but asymmetric key is more secure because here we are having two keys. Okay, so here if I encrypt with one key, even if that key is compromised, no one can decrypt it because the decryption only happens through the private key. Okay, so having that extra key makes asymmetric algorithm more secure, but here it is very slower because you know encryption and decryption is handled through a very difficult mathematical models. That's why it is much slower. Okay, and symmetric encryption is preferred if you are sending more data across the internet because it is much faster. Understood? Clear, guys? Any questions? So now we understood how do you encrypt and decrypt the data. Let's understand what is SSL or transport layer security. Okay. So going back to our earlier discussion, so we said that whenever you're trying to send the data across the internet, so there is a chance that some hacker can read your data. Okay, so you need to protect your data by employing some sort of encryption. So it can be symmetric key encryption, it can be asymmetric key encryption, but you need to make sure that the data that you are sending is encrypted. Okay, but the question is how will you encrypt the data? Okay, so we know that we have symmetric and asymmetric. Who is going to have those keys? Okay, whether it is your browser or whether it is your actual server or the application that is serving it. Okay, now let's understand it clearly. Okay, so TLS is a protocol that we use to encrypt the data between two different applications. So ideally it will be from your browser and your web server. Okay, the server that is handling your application, but it is not always browser and the server. It can be server to server also, it can be from client to server, it can be a use between a user, and it can be a server, it can be anything. Okay, it is not always browser, but browser here we call it as a client because we only access web applications through the browser. Okay, now using TLS we can make sure that the data that is sent across the two different machines is encrypted and it is updated version to SSL. If even if you see this SSL or TLS, it is both are same. Okay, and also this TLS security ensures that the eavesdroppers and hackers are unable to see the data. Of course they can see the data because it is through the network, but the thing here is they cannot decode the data because it is all encrypted. And we should definitely visit the sites only with HTTPS. Okay, so this is a secure form of HTTP. Again, we will come back to it. Okay, so using HTTPS site, we can be rest assured that the data that you are sending to the server is all encrypted. Okay, and what is an SSL certificate? Okay, so here when we talk about TLS or SSL, we will talk about the certificates. Okay, so what is a certificate usually? It's an identification, right? That you achieved something, right? It proves your
Yeah.
worthiness. Okay. Similarly, whenever I'm trying to buy a domain, or let's say I'm hosting my own Facebook kind of an application. Okay. So I should be I should make sure that that domain belongs to me, and I should assure the users that they are talking to the right domain or the right application. So how do I make sure that, or how do I ensure that security in the first place? By having a certificate. That certificate says that that domain is mine and I am the original owner of that website. Okay. Like if you see bank have their own URL. So they will have this certificate. That certificate says that they are the original owners of that domain so that people can securely transact with them. Okay. So that's why whenever any website, if you visit on the HTTPS, if they have a valid certificate, you will have this lock symbol, which means so it is encrypted. The data is encrypted. But if you visit insecure sites, the sites which are hosted but they doesn't contain any kind of a certificate, then you will see that not secure. And mostly in Chrome browsers, they will not even allow you to move forward unless you accept certain things. I'll tell you. Okay, clear? But what exactly this certificate contain? I'm saying SSL certificate, the domain which has the SSL certificate. I can be rest assured that I'm talking to the intended recipient. Okay. But what exactly this certificate contains? This certificate contains the public key. Okay. See, anyone, so for in the internet, I can take anyone as the a user. Okay. In fact, the web application itself can be a user. Okay. Which means it should have its own public and private keys. Okay. But the thing is, anyone can generate this public and private keys, right? If I have a account like banking website called banka.com. Okay. In fact, I can also create my own website banka.com, and I can also create my own public and private keys, right? Then how do I differentiate between the this genuine banking site and the hackers or the attackers site? Okay. So for my domain, I'll get a certificate. Okay. So that certificate will have the public key, and private key I'll have it separately. Okay. So those who wants to talk to me, I'll just show my certificate. Then they can validate me, right? Or they can authenticate me. Then they can easily talk to me without any worry. Okay. So here digital certificate contains the owner's public key, the name of the CA that issued the certificate. Okay. So from where you are going to get these digital certificates, and who is going to certify you that you are the original owners of that domain or that website? So someone has to certify, right? Correct. That's why we have certificate authorities. So these certificate authorities will certify you. Okay. So if you send them a request that you are the original owners of the domain, they will issue a certificate after a rigorous verification. So they will issue a certificate that this domain belongs to this particular person or the organization. Okay. So let's say there is this site called bankb.com which is managed by a hacker. Okay. If he tries to get a certificate from the certificate authority, we also call it as trusted CAs or trusted root CAs. Okay. They will simply reject them. The thing is, they may not have proper details with them. While verification, they might fail that verification. Okay. So CES will never issue certificates that easily without any verification. Got it? Understood, guys? Clear?
Yeah.
Okay. Now let's understand where these certificates are actually used by going little by going one step backward. Okay. So here I have a website. Okay. So here website, we know that it directly cannot run, so it has to be hosted in the web server. Okay, so here I have my banka.com web server. Now I have the client here. Okay, let's assume the client is nothing but the browser. Now browser has to securely send the data to this website, which means I need to send the encrypted data. Okay, so how do I send the encrypted data? Which means I need to do some encryption. Okay, so for encryption, there are two ways. One is the symmetric encryption and the other is asymmetric encryption. So for now, let's talk about the asymmetric encryption. So for asymmetric encryption, I need two keys. Okay, so one is the public key and the other one is the private key. Okay, so what I'll do in this case is this banka.com, this is a domain, right? I will create two keys, or the owner will create two keys. One is the public and the other is the private. Okay, so here whenever I try to connect to this particular website, so this banka.com, okay, so it will send me its public key. Okay, let's assume it will send me the public key. Now whatever data that I wanted to send, I will encrypt it with the public key. Okay, so this has generated some random information. Now that information is sent over the internet, and this banka.com received this 1234. Okay, now if you see, the original data is encrypted with the bank's public key. Okay, now what I have to do, what bank has to do, bank has to use its private key to decode the data. Okay, clear? Understood? Clear, guys?
Yeah, got it.
Okay, so this is about encryption. But so do you think that this is a proper way of encrypting and decrypting the data? Should I need any other things here? Because my main motto is to encrypt and decrypt the data, which I've achieved. Okay, so let's see from the hacker's perspective. Okay, so what if this public and private key are from the hacker? Okay, let's say the hacker has its own banka.com. He has changed the URL like AA.com. Let's assume it's like this. Okay, so instead of you talking to banka.com, you have added extra a, and then the data is sent here. Okay, now when you initiated the request, this banka.com will have its own public and private keys. Then it will send the public key to you. Then what you will do, you'll take your data, encrypt it to the public key to generate the information, the encrypted information. Now you will send it to the bank. Bank will receive it, and then they will use the private key to decode the actual data. Okay, correct? Correct, guys? So your
Perfect.
hacker is able to get your data easily. This is the issue here. The issue here is whenever you're getting the public key, you are simply encrypting the data without checking whether this public key actually belongs to the correct bank or the server that is being run by the hacker. Okay,
So it has to
clear?
prove its identity first, right?
So it has to prove its identity that this public key belongs to the original bank site but not from the any hacker. So how do I do that? So here, that's the reason why this public key has to be certified. So what I'll do is I'll ask my certificate authority to certify my public key. So once I do that, it has to go through some verification that this domain belongs to me. In fact, the certificate authority contacts, even they sends an email, talks to me over the phone, verifies whether this actual domain belongs to me or not. So it all does a lot of things, and then they will issue a certificate for me. That certificate will have my public key. Okay, clear? Now whenever I initiate the connection to the bank.a.com, instead of sending the public key, they will send the certificate. Okay, mybank.com will send a certificate. Now by looking at the certificate, I can verify whether that certificate actually belongs to the bank or not. Okay, again, see here how the hacker what hacker does here. See, getting a certificate is easy. Okay, so here certificate, I can create a certificate myself. Okay, which means this certificate, even though it is issued by CA, this hacker can create his own certificate without the needing for CA, and then instead of sending his public key, he'll also send a certificate. Then my browser receives it. Again, it's the same old story, right? Again, how do I verify that certificate is itself given by CA or not? Correct. Because it is easy to create a certificate, everyone can create it. Now what browser will do is, browser does this checking whether the certificate is actually signed by the CA or by hacker who has his own CA. Because creating a CA is very easy, I'll show you in the demo. It's very easy. Okay, so how do I certify? Okay, first thing you need to understand how this certificate is issued by the certificate authority. So how this certificate is actually created? So this certificate is created with the, see, CA. Again, as I said, everyone is like a user here. Okay, this CA himself will have his own public key and a private key. Your websites will have its public and private keys, a user will have public and private keys, everyone should have it. Now, whenever CA issues any certificate that has the domain's public key, it encrypts it, or it signs with its own private key. Remember, so whenever it is creating a certificate for you with your public key, it signs it with its private key. Okay, which means I can only decrypt with its public key, right? As I said, public keys can be anywhere, right? I can easily share it. So what will happen in case with CAs is, CAs, all public CAs, most common CAs, public keys are available in your browser. Because public keys are not, like a secret information, I can put it anywhere. All browsers will have most common CAs public keys. I can in fact show you. Okay, so if you open your browser, and if you go to your settings here, and go to this privacy and security, and then security, go to manage device certificates, and if you click on this trusted root certificates, you can see here there are a lot of CAs who are publicly trusted, like Global Sign, DigiCert, Komodo, GoDaddy is also there, Global Sign, one from Norton, that is VeriSign. Everyone's public certificates are here. Okay, and since this particular certificate is signed by CS private key and CS public key is already in the browser, browser can verify whether that private key belongs to the CA or not. If it belongs to the CA, then this certificate is signed by the actual CA. Clear? Understood, guys? Any confusion?
Okay.
Okay, now the certificate comes with the private key of the domain. Now the browser will see whether the certificate belongs to the actual CA or it is a fake CA by looking at the public key of that CA. Because the certificate is signed by the CA's private key and CA's public key is already there in the browser, browser can easily decode this certificate and see whether it is the actual CA that signed it or it is a fake CA. Then once it verifies that it is signed by the actual CA, it is going to display that padlock with HTTPS in the browser. Otherwise, it will simply show the notification that this is an insecure site. Clear? Okay, so this is how a certificate authority issued certificates are trusted by your browsers, because browser will have all the root certificates inside it. Okay, so here what is a root certificate means? Root certificate is nothing, it is the CA's public key or the public certificate. Okay, certificate means again it is a public key, always remember it's not the different thing. Okay, so here a CA can have intermediate CAs that can issue certificates on the behalf of the actual CA. Okay, so we call all the main CAs as root CAs, and then if they uh, use intermediate CS, then they call intermediate. Then intermediate CS can actually issue certificates. Okay, so this is called as a certificate chain. Okay, like there will be root CA who wants to delegate their task to the intermediate CS. Now intermediate CS actually sign your certificates. Okay, so maybe this process of whatever I explained is not very clear now, but trust me, I'll show you how this is actually done by protecting your web servers and in Kubernetes how to implement this. Now if you look at the certificate details, okay, if you go to any let's say I'm in my GitHub page, so if you click on this padlock and click on this connection is secure certificate, so you can see all the certificate details. So the certificate is assigned or given to github.com. Okay, and this is issued by DigiCert. Okay, this is the certificate authority, so it issued it. Now if you go to details, you can see here, so this is the DigiCert root certificate, root CA. Then someone signed it, so this is the intermediate CA. This is your actual certificate of the domain github.com. So this is the certificate hierarchy, you can say that certificate chain. Okay, got it. If you take any of the website, you can actually see the certificate and who has actually signed it. Okay, so Amazon has its own certificate authority, so Amazon root CA, so the root Amazon root CA actually signed that certificate. Got it? Okay, clear guys? So whenever you're generating a private and public keys of your domain, you need to actually get a certificate from the CA, then only it will be trusted by your browsers. So simply using public and private keys for the encryption doesn't work. Okay, because a fake CA or any man in the middle can actually generate his own public and private keys, okay, and impersonate you. That's the reason why you need to get it certified. Now here, this these are all the public CAs whatever we talked about, like DigiCert, Komodo, Global Sign. Okay, these are all public CAs, which means they can only certify something the domains which are publicly available. Okay, like github.com. The github.com is publicly available domain, it's not restricted to any private organization or something like that. Okay, right? So these are all called public trusted CAs. Okay, so they issue certificates for all the public facing websites and the applications like the Symmetric, DigiCert, GoDaddy, Entrust, VeriSign. Okay, so what if I need to enable SSL communication between the applications internally to my organization? Okay, so there are two ways. So one is to make your application public, which is not the option for us because we need to restrict our applications to the internal organization. So for that, what we can do is we can actually deploy our own private CA. Okay, because these CAs, you can create your own what do you say, you can deploy your own CA. So all the public CAs will in fact offer their own private or internal versions, okay, offerings. So you can deploy your own CA and manage all the certificates internally. Okay, by paying the trusted public CA some money, they can actually deploy your CS, which we call them as private CS, which we usually set up inside your internal organizations. Okay, for all your SSL and TLS needs, like Microsoft CA. Okay, got it guys? Any question,
No, Vikram.
guys? Okay, now let's understand this HTTPS. So HTTPS is an encrypted form of HTTP. Mainly we use for encrypting the data over the internet. So it is just to increase the security. And nowadays all the HTTP sites, okay, are flagged by all the major browsers. So you will not be able to access those sites without actually, accepting certain terms. Okay, I'll show you in some time. After that only you'll be able to access non HTTPS sites. Okay, so how to convert your HTTP connections to HTTPS? It is simple. You need to use transport layer security, that is TLS security. And we know that TLS includes a certificate for your web server. Then once you install your certificate, your HTTP becomes HTTP. Yes. Okay. So way to install the certificate and all, I'll tell you. Okay. So don't get confused. So if you have SSL or TLS certificate for the website or the domain, you can actually implement HTTPS. Basically, HTTPS uses TLS to encrypt the communication. Okay. Like in HTTP, the plain data is sent, and in HTTPS, because you are using TLS certificates, your data is encrypted between the client and the server. So usually your clients will be browsers in many cases. Okay. And also we have a lot of advantages if you run your applications on HTTPS. One is your website API is legitimate and trustworthy, so that users can actually access your application without worrying whether they're talking to the correct website or a fake website. And also HTTPS helps search engine optimization. We know that Google ranks a website based on HTTPS, so it won't rank any website which is running on HTTP. Okay, even in your search results it won't be visible. Okay, so in order to gain more trust from your users, you need to enable HTTPS. And also, it is safe from snipping, because as you know, the data is encrypted. Okay, now let's understand SSL handshake. Okay, so here in the earlier uh, example, whatever we discussed about how the certificate can be used to authenticate yourself, or to make a website genuine. Okay, so here uh, we understood how to get a certificate and all, but we did not understand how actually the certificate is transmitted, and what is end-to-end process before the actual encryption. Okay, so we need to talk about SSL handshake. So before you access your website, or you see your website on the browser, there are a lot of things that happens in the background, so we call it as SSL handshake. Okay, so SSL handshake means whenever you try to connect from your browser to your website. Okay, so this is the actual method that happens underneath. Okay, just a second, guys. Okay, so the session starts with the client authenticating the website. That is the first step. That is, it will validate whether Amazon.com is the actual Amazon.com by Amazon, or it is a fake website hosted by the some fake hacker. Okay, some hacker, and that is the first method. Once it verifies the website or the server, the next thing is it shares a session key. Okay, so here we will not be using asymmetric encryption because it is very slow. We need to use symmetric encryption, which means we need to have a common key between the browser and your server. Okay, so the first step in the SSL handshake is to authenticate or verify this server, and after this the browser will send a symmetric key or a session key to the server. Okay, now that key will be there between your browser and the server. What will browser will do? Browser will encrypt the data with that key, and the server will decode it with the same key. Okay, now let's understand in the perspective of hacker, so how this server, how this client sends the shared key, okay, across the internet. But here this hacker will not know about it, cannot decrypt that session key, because if he decrypts that session key, and if he has the session key, in fact he can also sniff on the data, which will not happen in case of SSL handshake. Okay, and all this entire end-to-end method will be completed in within seconds, so you won't even realize. Okay, now first step of the SSL handshake, okay, is to create a public and private key for this particular server. Okay, so you're hosting amazon.in, you need to get a certificate for this domain. Okay, certificate for this domain, in the sense, what is this, guys? So you need to generate a public and private key, right? And then you need to get a certificate from CA, right? Certificate authority. Okay, so the certificate will have the public key. So that's why I'm not telling about the public key, because the certificate means it will have the public key. And also remember, this certificate is issued by whom? It is issued by the certificate authority. Okay, so the certificate authority, what it will do, it will actually sign it. Okay, so which means the certificate will have the public key of the domain, the CA which actually issued that certificate, and also there will be an expiry date. Okay, I'll extract the certificate and show you. It will also have the expiry date, because the certificate cannot be valid for forever. So you'll also have the validity, let's say 1 year. After 1 year the certificate expires, then you need to renew that certificate. Okay, now how do I get the digital certificate? So you will send the public key. Okay, so your public key will be, right, your public key will be signed with CA's private key, correct? Right, guys?
Yes.
Then only your browsers can actually validate this certificate, right? So your public key will be signed by the CA's private key, and then it will generate your server certificate. So server, in the sense, your actual domain certificate. Okay, now why it has to be certified or signed by CS private keys? So whenever I connect to the browser for the connect to the application for the first time, the server will automatically send that certificate to me. That is the first step in the SSL handshake. Now, by looking at the certificate, how do I know that it is signed by actual CA, or it is signed by some a fake man? Okay, so here, since its certificate is signed by CS public key, and all the browsers will have all the public keys of all the root CS. Okay, so your browser can actually validate whether it is the root CA or the trusted CA that signed it, or it is a fake CA. Okay, now the next step here, see, as I already said, if you have a public and private key files, I can actually encrypt the data with the private key, sorry, public key, because whenever you connect to the application for the first time, that application is going to send you the certificate with the key, public key. Since I already have the public key, I can encrypt the data with the public key, and your web server can actually decrypt it with the private key. But as I already said, this method is very slower, because it is using asymmetric key encryption. Since it is very slow, I'll be going for symmetric key encryption. Okay, so the first step is here, once your server receives the server sends the certificate and it is received by the browser can validate your domain, so that step is completed. Now, since I have the server certificate with my browser, what I'll do is, instead of directly encrypting my data with that key, what I'll do is I'll create a session key. Okay, it is not data yet, it is just a key which your browser created it. Okay, now I will encrypt it with the server's certificate or the public key. Then this data is sent over the internet. Now my server also received that encrypted data. Since it is encrypted with its public key, what it will do is it will decode it or decrypt it with its private key. So that encrypted data is now decrypted. Now what it will have the key, right? Because I sent only the key, right? Correct. So what if this data is also available here? Okay, now let's take one step back. The first step is sending a certificate. So the browser receives a certificate from amazon.in. Let's assume that certificate is also received by him. Okay, now the certificate is also here. Now I created a session key and I encrypted it, so that data is going through the internet. Now let's assume he also has this data here. Okay, that folder which is encrypted with this certificate. Okay, so this is the encrypted data, and he also has a server certificate. But will he be able to decrypt it? No, right?
No, cannot, since he
Because his
doesn't have
private
this.
key is here. Okay, that's why even if this data is sniffed, this hacker cannot actually do anything. Now this session key is safely sent to the server, so even your hacker cannot know it. Now I have the session key. All the future communications are encrypted with the session key, and it is decrypted at the server end with that same key. This is symmetric encryption. So here your SSL handshake start with your server sharing its certificate and your client sharing the session key. Now all the future sessions communication is encrypted and decrypted with the same key. So this is the SSL handshake. Okay, so this method is valid for all the web applications anywhere. If you remember TLS, always remember this is the only method. This browser can be a user as well, or this browser and this amazon.com can be two different servers implementing TLS in between them. This server will send its certificate, this server will validate it, it sends the session key, and both of them will talk over that session key. Okay, so if you see here, there are certificates involved, private keys involved, session keys involved. Okay, you need to understand this. Okay, now briefly again, so how this SSL handshake works. The first thing is inside your browser, you'll enter the HTTPS website, like say bank.a.com. Now that URL reaches bank.a.com. Now what bank.a.com will do? Bank.a, it will share its certificate. Now what browser will do? Browser will validate that certificate because it has CS all public keys and certificates assigned with CS private key. It is authenticated. Now once it is authenticated, the browser will share the session key by encrypting that with the server certificate it received. And since that data is now received here, server will decrypt it with its own private key, and the shared key which is sent by the client is now received by the server. Now all the future communications are encrypted and decrypted with that key. Okay, so if you are confused about what keys are sent over the internet, always remember you should never share your private keys. It is always public key. Okay, when I'm saying we are sharing the certificate will have the public key. That's why it is being shared across. Okay, and who is going to implement all this, like issuing the certificates, revoking the certificates? Okay, controlling who can actually request for a certificate, the hardware, the software part. So everything is called public key infrastructure. We call it as PKI infra. So within your organization, if someone says PKI, which means you are implementing your own certificate authority internally within your organization by either taking that private version of the public CAs or setting up your own CA. Okay, since CA means they need to have a proper software and understand to whom the certificates are issued, in how many days they are going to expire, who requested it, at what time they requested it, and what devices actually using those certificates, or in which web server those certificates are involved. You need to have all that information. Okay, that complete thing is public key infrastructure. We call it as PKI infra. Got it? So there are multiple components involved in PKI, like the certificate authority, which can actually issue the certificates for the domains. The registration authority, or this registration authority, also known as RA, it maintains or verifies, okay, basically who is actually requesting for a certificate. Okay, so not everyone can request for a certificate, right? So only the valid users or the devices should request for a certificate. Okay, and sometimes the certificate issue should be very instant. Okay, let's say certificate got expired, so within an instant the certificate should be renewed, which means there should be someone who should be monitoring all these activities or verify whether correct people or the devices are actually asking for the certificate or not. And then there is a certificate database, a central directory where all the key certificates are stored and managed. Okay, and there should be also policies outlining how these certificates should be issued, when they should be revoked, what should be the validity of these certificates. There should be central policies and guidelines managing all this. Correct? Correct, guys? Understood?
Yes. Yep.
Okay. Now there are a lot of certificate types. We have client certificates, server certificates, self-signed certificates. So all these are important. Okay. If you're working on Kubernetes authentication part, you need to know all this. What are client certificates? Okay. So if we go back to our previous discussion, so here browser is asking, browser is trying to validate the server. So we call these as server certificate because server is trying to prove its identity. What if server asks the browser or the client or the user to prove its identity? Correct? So in case of Kubernetes, what exactly we are doing? So we have the kubectl utility. So this kubectl utility, it talks to the API server for all your operations, right? So here API server is nothing but the server component. Okay, and this is the, let's say, your client. So you're trying to read the or get all the pods in all the namespaces, let's say so. Okay, so will the API server send you that information immediately? First it has to validate whether you are the authenticated client or not, right? Correct? Clear, guys?
Yes.
That can be in the form of username and password. That is one form of authentication. The other form of authentication is the username plus tokens. That is another form. The third form is having the certificates and the private keys. Okay, that's why if you open the kubeconfig file of the admin user will have his own certificate and his own key. Now when kubectl issues a command to the API server, it is also sending the user certificate and key, right? Now the server is validating whom? The server is validating the client. Correct? Correct, guys?
Yes.
Okay, but if you are using browser to access a bank website, the bank may not authenticate you, bank may not need your keys. Okay, because if bank asks for the user certificate, right, then the user certificate also has to be signed by some CA, right? Because this is not happening in our case. That's why some servers may not ask for the user authentication. That's why you access it from any browser, bank may not actually ask for the user certificate, user authentication. So here client certificates means client has to prove his identity. Okay, now these client certificates also are to be signed by your certificate authority. Otherwise, a server will not authenticate you even though you have client certificate, but server may not authenticate you because the certificates are not signed by the CAs. Maybe it is signed by you or it is signed by some unknown CA which is not known to your server. Okay, and all these certificates, right, usually in the form of X.509 standard, So there is a specific format in which if you decode that certificate, a lot of information will be displayed. Okay, so that is called X.509 standard. Okay, in case of server certificates, as we already know, these certificates are used to authenticate or prove the identity of the server. Okay, so whatever we had seen in the earlier example, it is the server certificate. The server certificate you can issue to a server with a specific host name, or it can be a simple domain like www.google.com. Then you need a domain certificate for that domain and a domain private key. Okay, since when you're talking to the web, when you're using a web browser to talk to an application, the application is sending its certificate back to the browser. So here the server is trying to validate itself. Okay, so you are trying to validate the server. Those are called server certificate. Now here, what is a self-signed certificate? Hmm? Right? What is a self-signed certificate? Now let's understand how this signing process usually works. Okay, let's assume I am the user. I have a public key. Okay, and I have a private key. Now I want my public key to be certified by some CA. Okay, so what I'll do, I'll ask CA to give me a certificate. Okay, so it will give me a certificate. So this certificate will have my user public key, right? And then it is signed by CA's private key. Correct? Correct, guys? So which means this certificate which I received, okay, is from the CA. But I don't have a CA. I want to certify myself. What should I do? I'll take my public key and I need to sign it with some private key, because signing will only work with the private key. Since there is no CA, I'll use my own private key to certify myself. Okay, this is called self-signed certificate. A certificate which is signed by our own private key. We are not dependent on the other private keys. You're signing your public key with your own private key. Understood? This is easier, right? You're not dependent on any CA. You don't have to prove your identity to the CA. Okay, you don't have to wait. So whenever I need a certificate, I'll immediately self-sign it. Okay, so that I can at least have the HTTPS communication, although it is not safe, and although there is you know many browsers will not actually verify it, because no CA signed it, which means browsers will fail the authentication part. Okay, so browsers will still see the encrypted traffic, but the problem here is they will not be able to identify the CA. Okay, because you only signed it. Got it? Clear, guys? So we can use OpenSSL to create a public key, private key, and you can create a certificate. But this certificate is not at all valid for the public website. No one is going to accept it. Okay, and the advantages is you can be your own CA. You don't have to pay for the certificate because CA is not signing it. You can create n number of such certificates. You can quickly enable HTTPS in your test environments because you're already having the certificates, and easy to manage it. I can create hundreds of such. But the problem is, whenever you try to access a website, if that website is using self-signed certificate, which means the website public key is signed by its own private key. Okay, although the data is encrypted, if you see in the browser, this address bar, it is still HTTPS. But the browser, what it is saying error certificate authority invalid, which means this certificate is not signed by the trusted root CA. It is signed by someone. It can be a fake CA, or it can be any private CA, which browser is not able to trust, because that private CA, if it is signing your certificate, that private CA's public key or the public certificate should be available in the browser. If it is not available in the browser, your browser is going not going to trust it. Okay, but if you see, if you click on this advanced tab, you can still visit this website, but your browser is going to warn you. Clear? Like this. Okay, if you see here, I'm hosting a website called mynginx.com, but the certificate is not signed by any CA. It is signed by its own private key. This is a self-signed certificate. Clear, guys? So try to avoid these websites which shows is not secure. Okay, although it is encrypted, it is very easy to decode it because this is not the this certificate is not signed by the actual CA. Okay, so there are a lot of disadvantages of self-signed certificates. You cannot use it for production or public facing websites. Your browsers are not going to trust them because browsers will not have the public certificates of these CS. Okay, and here anyone can create a self-signed certificate, which means managing them becomes very difficult. You'll end up creating multiple self-signed certificates and all. Okay, and security team often will not allow it because they cannot actually what do you say, monitor how many of them are being created, where exactly these are being used. Okay, how the private keys are being stored. Okay, so it is quite hard to track all the self-signed certificates. Okay, that's why security team will not allow you to create self-signed certificates. You need to use only the certificates which are approved by the CA by sending a formal request to the CS. So we'll continue the rest of the part tomorrow, where I'll talk about some more certificate types, and then I'll show you how to implement TLS for your Nginx web server, how to create your own CA, how to use self-signed certificates, how to install root CA certificates in your browser. Okay, so a lot of interesting things are available.